Material for medical device. I'm Ethan Laiban and my ID number is 2024630254. The requirement in strength and properties for material in medical application and the most important criteria that the material should meet. Strength requirement. Mechanical strength. Tensiles and compressive strength. It withstands forces like pulling, for example, sutties, and compression, for example, bone implants. Fatigue and wear resistance. It endures repetitive stresses and minimizes degradation. For elasticity and durability, match tissue flexibility, for example, ligament cartilage, and provide long-term performance in load-bearing applications. For functional properties, biocompatibility. Material must not provoke adverse immune response, toxicity, or chronic inflammation. Corrosion resistance. Resistance to saline, enzymatic, and acidic environment of the human body, for example, stainless steel or titanium. And finally, sterilizability. Must tolerate sterilization method like autoclaving, ethylene oxide, or gamma radiation without degradation. Most important criteria for medical materials. First, biocompatibility. The material must not harm the body, cause toxicity, or trigger an immune response. Sterilizability. It must withstand sterilization without losing structural integrity or functionality. Mechanical strength and durability. Sufficient strength to withstand expected loads and mechanical stresses for the intended application. And finally, corrosion resistance, especially important for the implant exposed to the body fluids to prevent material degradation. The development of sustainable materials for medical devices align closely with global sustainability goals by addressing environmental, social, and economic challenges. Number 1. Reducing environmental impact, SDG 12, responsible consumption and production. And the points are eco-friendly manufacturing. Sustainable materials often use cleaner production process, reducing emissions, energy consumption, and waste. Number 2. Promoting health and well-being, SDG 3, good health and well-being. And the points are non-toxic alternative. Sustainable materials avoid harmful chemicals, improving patient safety and reducing risk to healthcare workers during manufacturing or disposal. And number 3, advancing innovation and infrastructure, SDG 9, industry innovation and infrastructure, circular economy. Design devices for reuse or recycling fosters innovation and supports a circular economy in healthcare. Number 4, supporting climate action, SDG 13. Climate action. Sustainable materials reduce dependence on fossil fuels, mitigating the contributions of healthcare systems to climate change. Hospital adopting eco-friendly device contribute to broader climate resilience effort. The development of sustainable material in medical device align with global sustainability goals. Number 1, polylactic acid, PLA. Why? Derived from renewable resources like corn, starch, or sugarcane. It is biodegradable, which are reducing medical waste and environmental impact. Suitable for applications like sutties, implants, and drug delivery system. 2. Silicone. The reason is non-toxic. It is non-toxic, biocompatibility, and highly durable. It is reusable and recyclable in specific settings and suitable for catheters, prosthetics, and implants. Number 3, hydrogel, for example, alginate or chitosan based. The reason is derived from natural material like seaweeds, which is alginate, or shellfish, chitosan. Biocompatibility, biodegradable, and excellent for wound care, drug delivery, or tissue scaffolding. And number 4, titanium and its alloy. The reason is lightweight, corrosion resistance, and highly durable, and ideal for orthopedic and dental implant. The future of materials in medical devices. Number 1, smart materials, for example, shape memory alloys, which are nitinol, used in stents or orthodontic wires that change shape in response to temperature or stress. The reason is enable device to adapt dynamically to physiological changes. Number 2, biodegradable and resorbable materials, for example, polylactic acid, PLA, or polyglycolic acid, PGA, used in sutties, tissue scaffolds, and drug delivery system. And the reason are reduce the need for removal surgeries. Number 3, 3D printed and patient-specific materials. For examples, custom implants, 3D printed titanium or PEEK implants for orthopedic and cranial reconstruction. The reason is enable precise, patient-specific designs. Number 4 is sustainable and eco-friendly materials. And the examples are bio-based polymers derived from renewable sources like cellulose or algae. For examples for packaging or disposable device. The reason is address growing concerns about medical waste and environmental impact.